So Yanesh and I, it seems like we've been doing this for years, where I introduce him to a talk. The audience was always intrigued at what Jendamark, which Yanesh co-founded in PE, has achieved since the early the mid 1980s, where they did advanced automation systems initially for the automotive industry and then expanded over the years into India and recently also into the US. So people are also amazed at the amount of advanced manufacturing that is possible in South Africa at the tip. So Yanesh, as a mechatronic engineer, graduated from UCT, has got a lot of depth in what he talks about. Today, he's quite popular. You'll see a lot of clips of his talks on LinkedIn, where he talks about advanced manufacturing, and also the topic today, which is really around, if we've got all these advanced systems, then why is the adoption so slow? And I'm just paraphrasing the topic somewhat, but Yanesh will give his insights from what he's seen around the world, and of course in his own Jendamark, where they manufacture these advanced systems and also had experience with adoption. So with that said, I don't know if there's anything else to say, but I'm sure you'll introduce aspects of what you do as well during your talk. So welcome again, and thank you very much for joining us in this table talk. So with that said, Yanesh, over to you, and thanks again for making the time.
Thank you, Dino. Thank you to the rest of the CCIG. Fantastic opportunity for us. Yeah, so as Dino mentioned, we've been on this journey for quite some time now. And obviously our journey started around making machines for factories. And we've evolved into what is, I'll say in inverted commas, smart manufacturing. And we've been through the hype, and now we're sitting with the realities after the hype. And I guess we've learned a lot of lessons of, as the title says here, what not to do when you want to digitize. And I don't know if we'll have a whole bunch of solutions at the end of this presentation, but I thought what makes sense is to share with you some of our challenges that we've experienced. And it'll be great, maybe if we have time at the end, to talk more about what those challenges are, to see if there are common challenges across different industries. But I thought what makes sense is to spend 2 or 3 slides to give you an overview of Jendamark and who we are and what we do first. So as a one-pager, this is kind of what we do. So we design and build production lines that assemble automotive components. We are a team of about 800 people. Started in PE, Tebega, as Dino mentioned. We have about 450 people in our factory here in PE. We also started about 10 years ago a factory in India where we design and make these production lines also out of India. So we're about just under 350 in India. We have a sales and service office in Germany, and last year we also opened up a sales and service office in the US. We also have 2 service partners, one in Mexico and one in China. Born out of the automation business, so to speak, and I'll show you a video clip after this, what the typical automation projects that we would deliver is what we call a digital manufacturing revenue stream or business. And I mean, Industry 4.0 term, I think, was coined almost 12 years ago. And, we kind of jumped on that bandwagon and started to create a bunch of digital products, thinking that we're going to be the next Mark Zuckerberg and become billionaires, but unfortunately not. Because I think there's some realities of digitizing things in a factory that are very different to the typical Facebooks, Ubers, etc. And that's primarily what I'd like to share with you during the next couple of minutes. And we also have now an extensive experience in a digital education business. This is really around how do we take this experience from the technologies that we've developed in these 2 first blocks and apply them to really scale education to underprivileged kids, from device to cloud-based platforms, etc. But that's a topic for another day. But if anybody's interested, please reach out and we can talk more about our digital education business. So what I prepared was sort of just over a minute video clip of a typical production line. So starting off here, you see an assembly line coming together on one of our shop floors. This is a sort of drone shot of the line kind of all ready to go. Here's another line on our shop floor, and here's some close-ups of some of the machines. So here's a differential production line for custom in the US. This is a BMW axle. Now this is a VW engine assembly line. This, I've paused it here, is a catalytic converter assembly line in VW in Germany. So I often tease our German colleagues in that they had to come to Africa to buy some of the most advanced technology, and I love rubbing that in their face. And we're very proud of the fact that we're able to send this advanced technology from South Africa to many places around the world, including, let's say, the home of machine building, Germany. These are some of the more complex machines, so metal forming machines. This is a hydrogen tank assembly line in France. This video was taken while it was on our shop floor. It's now actually in France building these hydrogen tanks. And here you see a wheel tightening station for the CS class. This is in Germany, in Singlefingen. And obviously, electric vehicles is a big factor nowadays. So this is what we call a cell sorting line. So this takes the little cells, does a bunch of testing on the cells, sorts them, basically laser welds the bus bars onto them. And this is what's happening here in this clip now, is laser welding the bus bars. And that's the final battery module. And that module will then get delivered into a pack. And that pack basically goes into the car. And obviously the car would then, the battery pack would provide power to the motors that obviously drive the car. So that's like literally a very, very, very quick overview of Jendamark and the kind of machines that we've built. I guess important to share would be this map. So out of our South African business, we've basically been able to deliver machines to almost every automotive hub around the world. So I'm pretty confident if there's an automotive hub, we've got some machine from Jendamark doing something. We've recently secured our first project in Saudi Arabia, which is an interesting opportunity. It's a massive growth market, and there's a big focus on manufacturing, but also automotive manufacturing. And so, although it's not colored in over here, we've just recently won this order to deliver an axle assembly line into a Saudi Arabian OEM called SIA. Yeah, so that's kind of our world map and where we've delivered machines. We're pretty proud of the fact that it actually comes from Africa. And we try and fly the South African flag as much as we can in different countries around the world. The next part I'd like to share with you is I've got two slides here of some personal experience with regards to digitization. So this is a product called Arcos, and it's a sensor that you screw on the back of your golf club. So I don't know if there's any golfers in the room today, but I'm a keen average golfer, and so I'm always looking for an opportunity to try and improve my golf. And so I bought these sensors, and basically every time you hit the ball, it measures where you hit the ball from. And so you can kind of measure, you can see here my drive was 237 meters, and then I hit my 54 degree, another 53 meters, which I obviously duffed, and then my pitching wedge was, I missed the green, and then you can see here the next shot was on the green, and I finally made 2 putts. And it kind of gives you this data over time, your kind of average distances and your accuracies, etc. All of this sensor that you get that gets stuck on the back of your golf club. And then it gives you some insights on where you should be improving. So it's obviously telling me I need to improve my driving, my 3-meter putts, etc. So it gives you kind of a whole bunch of insights on where you should be improving. So this is an example of digitization of my golf game. But what was very interesting for me, and I've had these sensors on my clubs for about 4 years now, 4 or 5 years. So I've got a huge volume of data on where I should be improving, the status of my game. But interestingly, my game has gone backwards. I've actually gotten worse. So when I bought these sensors, I think I was a 12 handicap. I'm now a 17 handicap. And the reason why I wanted to highlight this is that because I digitized doesn't mean that I got the result. And the primary reason why I went backwards was I stopped practicing. I didn't go to the driving range. I just spent less time playing golf, and I moved backwards. And so the message here is that just because I digitized, it doesn't mean that you get better. You still got to do the hard work. In contrast, I have another product. It's a Whoop. So it's actually this band that I'm wearing on my hand. I don't know if you can see my face, but it's this band I wear on my hand. And this is a very interesting product. Basically, what's nice about it is that you wear it 24 hours a day. So it's not like a smartwatch in that you typically take it off at night to charge. But this you wear all the time, and there's a little clip-on battery that you clip on that charges it, and then you clip it off and charge the battery separately. And basically, it monitors your your heart rate over time, and it divides the information into sort of three categories: your sleep category, your recovery, and your strain, which is basically your exercise. And it kind of gives you these metrics on how well you slept, how recovered you are, and how much strain you've actually done for the day. And it gives you kind of interesting information. It's also got a new feature here where it kind of gives you and predicts your current age. So I'm actually going to be 47 in September, but it's actually telling me I'm actually older than what I am. I'm actually almost 48, basically, based on the measures. And you can see all of the data points that it measures to determine my Whoop age, as they call it. And my pace of aging is 1.9. It's actually ideally should be less than 1, which means I'm getting technically younger, but I'm actually getting older at a higher rate than the normal rate. And so it's kind of giving me some interesting insights. And one of the important measures that it gives is sleep. And so here you see I've got a bit of a leaderboard going on here with some colleagues at work, including my wife. So this is my wife over here. And we kind of interestingly, over the last couple of years, and I've also been wearing this now for about 4 or 5 years, we compete on sleep, which is quite strange because they measure sleep and they give you a sleep score. And as you can see here, over the last month, I had a 76%, and I'm actually 5th on this leaderboard. And interestingly, what's happened over time is I've now really tried to concentrate on improving my sleep performance, not only hours, but also sleep quality. So you can click on this and you get your REM sleep, etc. But what's interesting is that one of the biggest impacts, or one of the biggest things that has an impact on your sleep quality is alcohol. And I've now pretty much given up alcohol because I'm desperate to improve my sleep score because I want to compete with my wife. And as a result of this, and also as a result of monitoring my recovery and my Whoop age, and weight plays a big role in this Whoop age, I've actually lost 15 kgs, improved my sleep, and I'm basically significantly healthier than what I was 4 years ago. So this, in contrast to my golf game, has actually had a big impact on my life, and digital has actually helped me perform and understand what I need to focus on. And the reason why I wanted to share these two examples is that the opportunity with digital is there to give you the information on what to focus on, but you still have to do the work. I think people still think that because I digitize, it's a silver bullet and it solves all of your problems, but it's not. Digital gives you the opportunity to see the information, to understand the information in a much more granular way, can give you the insights on what to do, but the reality is you still have to do it. And that's why I wanted to share these two different digital things in my personal journey, one with golf that's gone backwards and one with my general health that's actually gone forwards, to kind of illustrate the point. And this is the sort of catchphrase I tell all of our customers is that if you want to go digital, you have to make a decision on whether you want it to be a diet, which is a once-off kind of do it for 6 months and then you fall off the wagon, or are you going to change your lifestyle, which is a much harder thing to do over time. So if you observe your factory and you want to, make a significant change to your factory using digital, this is an important question to ask yourself. Do you want to do it as a once-off project and go back to your previous behavior, in which case it's a waste of money? Or are you going to fundamentally change the way you run the operations in your business continuously forever? Because that's how you're going to make the significant impact. And I think this is an important differentiation when you want to adopt digital. It's actually a lifestyle change. It's not a diet. So the next couple of slides, I was kind of debating with myself, do I show you some examples of some wins, or do I show you all of the challenges first? And I kind of, just before the meeting, I was swapping around these things. But anyway, I landed on, let me share with you 5 challenges we've experienced with our customers over the last couple of years. And then I'll show you some wins that we've actually achieved with customers from a digital perspective. So the first challenge is kind of leading into the previous comment of diet versus lifestyle. So this is, the idea of a digital project is actually not or a digital initiative is not a project. It's actually a strategy that needs to be adopted from a leadership perspective. I've not yet seen a digital initiative be successful without the leadership in the organization fundamentally adopting the change and actually embracing the change and living the change every single day. A lot of leaders in an organization, they want to make a tick box and say that we've digitized something and we've adopted some new technology, but they themselves don't want to change. They don't want to use the digital information that is now being presented to them. They want to stick in their lane and do what they've always done. And I've seen multiple projects, digital projects, fail in this regard because actually leadership are not buying into it. And so this is an important message. Probably the most important one is that if the leadership in the organization don't believe in the initiative and are not going to be willing to change their lifestyle in inverted commas, then it's not worth going down the journey. So that's been the first experience and probably the most important one that we've experienced. The second one is, and I deliberately put these worn out safety shoes, is because there's been so much hype around new technologies by these big consulting firms that kind of hype a whole bunch of things up, and they kind of, that's how they sell their hours, by hyping up, whether it be AI or IoT or whatever that is. But the reality is not many of them have actually spent hours on the shop floor, and their safety shoes don't actually look like this. So if the person coming to give you advice on how to digitize your shop floor, safety shoes don't look like this, then you should chase them out your factory, because when you digitize things on the shop floor, it's very different to digitizing things in your finance department or HR departments. The shop floor is a very, very different environment, and you gotta, in my opinion, you gotta have the real on-the-ground experience over time, and then understand the new technologies before you actually try to make changes on your shop floor. Because, I've seen far too many organizations spend millions and millions of dollars digitizing with no real impact on the business because they've been sold a dream. And I'm not a big fan of these consulting firms that sell dreams that have never actually spent a minute on the shop floor. The last one is, not the last one, the third one is shop floors have got hardware. And I think this is where people fall flat. So this is an electrical panel on the left-hand side. And anyone that has spent time on a shop floor has definitely come across an electrical panel that looks like this, unfortunately. I can tell you there's been a lot of maintenance and downtime on this particular machine, which is why it looks like this. And I think that this is where a lot of digital solutions fall short, because you have to integrate to this mess somehow, whether it be communication protocols that need to be understood, whether it be security issues, latency, because PLCs have to run at a specific cycle time. You can't have the machines running at unknown cycle times. You got to, take care of safety, etc. And probably one of the biggest challenges that we're experiencing with our customers now is that a typical maintenance department that's used to working with PLCs and mechanical elements of a machine are not equipped from a skills perspective to work with networking and new technologies and IP addresses and all of these kinds of things. And so, the adoption of these technologies has to be understood very well, and the skills in the organization also has to adapt to the new technology that's being adopted. Else, it causes more problems at the end of the day. And if you're not willing to take that leap from a skills development perspective within your shop floor maintenance department, then it's probably maybe not worth taking the leap from a digital perspective, because it's got to work kind of in parallel. The fourth one, which I found most interesting, and I don't know if any of you guys watched The Office, but this I thought was an appropriate picture, this challenge and resistance from middle management. So when we started to create our digital products and we applied them on the shop floor, what was very interesting for us, or what we expected, was a big resistance of adoption from operators and technicians on the shop floor. But actually we didn't experience that. We found a massive uptake from operators, from technicians that were very intrigued and very interested to adopt these new kinds of technologies. The majority of people are pretty tech savvy. They all know how to use smartphones. And so the idea of the tech adoption was not really a challenge on the shop floor. And obviously, typically, it was driven by some leadership within the organization. So there wasn't a challenge from adoption from a leadership perspective. Where the resistance and the most surprising part of it came from was middle management. Because what happens is you create a complete transparency from the operator or the machine to the CEO, because now you've got a connected system and everyone can see everything. And that can create a significant amount of anxiety, or this big brother effect for middle management that's sitting in between the operator and the CEO, where they're now being exposed to a lot of the information across the organization. And typically there's always a time delay in which, in the reporting cycles that middle management would make to senior leadership, or there was often some sort of manipulation of the information that gets presented to senior management, but now that's completely removed. And interestingly, the biggest resistance that we've experienced over the last 4 or 5 years from this adoption was actually coming from middle management, because there was this fear of being beaten by leadership, because leadership could actually see what the operator was doing on the shop floor. And I think this also comes back to the first challenge, where leadership becomes a more important role. So it's important that the leadership in the organization create a safe space for management to adopt this new technology. Else management see it as a big brother, or as a stick that they can be beaten with. And so it took us a while to try and figure out why were customers not adopting this technology. It makes perfect sense. Because, and I'll share with you one experience, what typically happens in an organization. We would pitch to leadership buy into it, they want to go through some sort of trial period, and they say, okay, no problem. And they'll tell middle management, please go try this new solution out. And so we would go around, implement the solution, get operators to buy into it. We spent a lot of effort trying to get the buy-in from operators and technicians, etc. And we were pretty successful with that. But the feedback that often went back to the leadership from middle management was, no, doesn't work. It's too admin heavy, or whatever that is. And once we sort of scratched that open a little bit more, we started to understand actually there's some resistance and fear of adoption of this technology, specifically from middle management. And then the last one was really around assembling the right team for success. And the main point I'd like to highlight here is that many leadership teams think that Industry 4.0 or smart manufacturing is actually an IT-driven project, which is certainly not. What we believe it's an engineering-driven project or approach, and IT is a supporting role. So what happens is you have an organization, and they would typically have some automation solutions or OT, operation technology on the shop floor, machines, etc. And that organization would typically have an ERP system or a business management system. And the leadership would then typically assign, because it's all techie and etc., the IT department to go and implement new technology on the shop floor. And there's a distinct difference between the way IT people work and view the shop floor and the way the engineering team or the maintenance team view the shop floor. And what happens is there's a big disconnect between IT and the shop floor. And so these projects never ever take off, because IT can never integrate to hardware on the shop floor. And it becomes very much an IT-driven project and not an engineering-driven project. And so what we believe is that it's got to be driven from engineers from the shop floor upwards, and IT plays a supporting role. They're not the primary role players inside an Industry 4.0 or a smart manufacturing opportunity. And I've seen far too many organizations where this is driven from IT top down and not from engineering or shop floor up. And it more times than not, I've seen complete failure and a waste of effort if it's driven by IT. And so the point here is that I think it's important to assemble the right team, having an engineering-driven approach, with IT playing a critical supporting role, but not the driving role. So I think that's the sort of last challenge that I wanted to share with you. So having been through those 5 challenges, I thought I'd share with you some examples of wins and successes that we've implemented with some of the customers. The first one, and this is kind of a summary of one of the solutions that we have with our customers, is where we've adopted what we call a smart operator platform, which is basically taking an operator which has got relatively low skills through a virtual reality training program. So this is a big advantage in that we can train operators repeatedly in an environment that is as close to the real environment as possible. It's obviously not the same as, but it's close. And here we can teach muscle memory, we can measure cycle times, we can create tests within the virtual reality environment, and it's obviously safer, and we're not creating risk on the actual shop floor. We then have created solutions that provide this, what we call digital work instructions. So here is a Ford differential that's being built, and here you see in front of the operators these dynamic work instructions where the operator gets given visual instructions. So here the operator doesn't need to know how to read and write. They just need to follow the pictures, and obviously we can change the languages here. And what's important here is the worker guidance, if you want, is actually connected to the hardware in the station. So there's an ID badge here, so we know which operator it is. And here there's a camera that's detecting that the operator puts the studs in the right position. You'll see that in a second here. And so the worker guidance is intuitive. It's, I'll just go back here for a second. You can see the red dots going to green as she fits the studs in the right position. That becomes important. And then we take it one step further with that same worker guidance now being integrated into semi-automated machines. So here you see an operator, this is in the US, a customer assembling a GM differential. As I said, this is a line we built for a customer in the US, and you can see the worker guidance. And this is dynamically changing based on the steps the operator has done and measurements that are being taken by this machine here on the left-hand side. And so the worker guidance is now orchestrating the human and the machine together. And now we're now able to optimize the process because now we can, as I mentioned, orchestrate the human and the machine together. The next example is that same Ford differential where we're now using AI to detect the operator performing the right steps. So here, for example, it's important that the operator fits the studs, you'll see in a second, the studs in the right position and bolts in the right position. So over here you can see there's two studs on the left-hand side where my mouse is. Here's a bolt, there's another stud. And so here we're using advanced AI to guide the operator on what to do. They're obviously getting the worker guidance in front of them so they know exactly the current state. And I think an important point that I'd like to highlight here, what's very critical in the digital side of things, especially from an adoption perspective, is that what we believe the right principle to follow here is that we should not be creating digital solutions that require extra training for the operator. We should be creating digital solutions that require less training for the operators. So the barrier to entry for the operator must be lowered because of digital. And the simple example that I tell a lot of our customers and our developers here is TikTok. So TikTok has lowered the barrier of entry for people to use the product. Not that I like TikTok, but it's an important principle is that you don't need training on how to use TikTok. You intuitively know. And so using this advanced technologies, we should be creating intuitive worker stations so that the operator needs minimal training. So we can reduce the training requirement, we can reduce the skills required, so we can enable more people to be able to work on the shop floor, not reduce the number of people and increase the barriers for them to work on the shop floor. So this is an important principle. Another technology using the same AI, this is a BMW X3 axle. Here what we're doing is, again, we're using, in this case, it's self-driving technology, like self-driving cars, where we're now able to detect the bolting tool. And you see the three dots on the bolting tool. And only when the bolting tool is in the right position do we enable the bolting tool to switch on. So if the operator is, say, for example, in the wrong position, the bolting tool will actually switch off. So what's critical in this operation is that they tighten in the right sequence, very much like your wheel bolt in your car. You don't tighten in a circle, you have to tighten in zigzag. In this case, tightening in this sequence is important for this particular product. And here's an example of how digital technology has not increased the skills requirement, it's actually reduced the skills requirement for this particular operator. Obviously, there's a display in front of the operator in case they make a mistake. What I tell customers is that if the operator makes a mistake, we also show them how to make the U-turn. So very much like Google Maps, if you're going down a road and you miss the turnoff, it automatically creates the new route for you to get back on track. So we are able to do exactly that using this digital technology because I know where the bolting tool is at all times. So if they move to the wrong position, we switch the bolting tool off and then we can indicate to the operator to go back to the right position. So it's almost like the U-turn if you want. And that's exactly how this advanced technology works for operators in this case. And then the last thing is really the use of data. And we've got a very interesting use case with one of our customers here in PE, where we show an operator dashboard that looks like this. And so here what you see is we create gamification. Just like my sleep tracking leaderboard that I showed, we've created exactly the same sleep or parts produced leaderboard. So here you can see Mr. J. Goliath is logged into this particular station, so all of this data is Mr. J. Goliath's data, and he is fourth in number of parts produced over the last 7 days. This is showing the operator which stations that he's worked on and how many parts, which operations he's performed and how many parts is produced by day. And very importantly and subtly, we're showing him that he didn't come to work on Wednesday because absenteeism is a big challenge in many factories. And so we're subtly creating a set of data that shows that he didn't come to work on Wednesday. That's, let's say, a subtle way to measure that absenteeism rate. But I think the most important part is these charts on the right-hand side here, where we show in green, wherever there's a green dot, these are the individual operations that the operator is improving at. And here where there's a red dot, these are the operations where the operator is struggling with. And so the operator can see their own performance. They can, decide that they want to get better. And we believe that 90% of people on the shop floor actually want to be better. They just don't know how. And we're providing the kind of information that enables them to decide how to be better. But interestingly, we've had one scenario or many scenarios, and I'll share with you one example where an operator, she was working in a particular station and one of her operations was scanning a barcode. And she got a similar graph like this where it was good, and then all of a sudden it started to slow down. And what was happening was the barcode quality was starting to deteriorate. And so every time she was scanning, she had to scan multiple times before she could actually get a pass on that barcode. And what she did was she called maintenance to her station and said to the maintenance guy, listen, the printer's 3 stations up. Why don't you go and change the cartridge inside the printer so that it prints the barcode better so that it can improve her own time? And that's a massive mindset shift that has happened with these operators, because now they are autonomously wanting to improve the production output and wanting and identifying the problems on the shop floor and autonomously taking action. And I think that's an important mindset shift that this data has now provided. And so the concept around here is data-driven behavioral change. So it's like Discovery, Insure. When you drive better and safer, they give you discounts at the fuel pump. So we're trying to apply this technology even on the shop floor for operators to improve themselves. Because I think the difference that digital can provide is that we typically run businesses using ISO procedures. And ISO is basically a top-down approach. So you have a board that decides processes and procedures, and then it trickles down to management and then down to the shop floor. And by the time it gets down to shop floor, it's a paper exercise, it's a tick box exercise, and actually the impact is really negligible. And I think digital provides the right kind of information for us to make a bottom-up approach. So that's an example of some of the data that we can provide an operator. I thought I'd share this chart. It's an interesting article I read from the Financial Times some time ago, and they talk about data and risk mitigation. So in the past, we would often make decisions based on our gut. Sort of production management people would like have a gut feeling of what needs to be done today to improve things. And what we want to do is we want to provide data to production people so that they move from this gut zone to the data zone. So if we can provide the right amount of data, they can make decisions that are much lower risk because the data is more relevant. And that also then reduces the dependency on experienced and people with a lot of tribal knowledge, if you want, in an organization, by providing the right kind of data so that decisions can be made to lower the risk at the end of the day. But one of the most interesting challenges that we see, and I'll show you some of the charts, is that production management is still in a reactive mindset. And the reason why I say that is, for example, here are 2 charts that are predictive in nature. So the first chart is what we call a ghost bottleneck. So this is where we show the stability of a production line, and simply put, here oil temperature plug confirmation cycle time is varying by 28 seconds. So this means that the cycle time of this particular operation is going up and down by 28 seconds, which creates this what we call ghost bottlenecks. So it's the same analogy like if you're on a freeway and your car is going fast and slow, fast and slow. Dino mentioned theory of constraints. It's exactly that. So you have the scenario where you have fast and slow, fast and slow. Overall, your cycle time gets slower and your output gets lower. So we are showing management where the variability is in the production lines. But because this is a predictive kind of chart, they don't respond to this. So nobody is interested in this. They want to look at OEE and see what happened yesterday, because the mindset is still not there to look to prevent problems for tomorrow, where it's just firefighting about what happened yesterday. Another one that's like really blows my mind that nobody looks at is this future bottleneck. So we simply show here that the wheel run out gauging over the last 7 days is trending slower by 0.6 seconds, and it's getting slower and slower and slower every single week. And so this is now telling you that there's a problem in the future. It may not be causing a problem now, but it's going to be a problem in the future. But you'd be surprised how many continuous improvement managers or maintenance managers or whoever they are, they ignore this information. It's kind of not interesting enough for them to respond to it because it's not a problem now, even though it's going to be a problem in the future. So this is an important maturity that I think is one of the biggest barriers that we've experienced in adopting new technologies. That this chart is really amazing. I think it is. It's telling you where the problems are tomorrow, but nobody responds to it because they kind of still think reactively, not proactively. And it's a lot easier said than done to change your mind, to predict your health, and as opposed to respond to a health problem that you have now. So that's again the health analogy coming into it. The last thing I'll share with you on the operator side is we're in development with the solution. We want to call it Odin Engage. This is where we want to create an engagement app that is really taking the employee information and how we measure their performance and how we gamify their performance and create rewards based on team performance or a team on a production line. How do we create a challenge? How do we measure that challenge effectively using the data and to drive the team to perform a lot better on a particular production line, as an example. So this is an interesting development that and journey that we're on at the moment. I was going to share with you a couple of solutions, but I think just from a time perspective, I think I'll skip that and just share with you some examples of some customers that have adopted some interesting technology. So SJM is one of our customers that has adopted a digital task management solution that we call Checkpoint. They are the second largest automotive manufacturer that makes these flexible couplings that basically connect your engine to your exhaust system, and basically these couplings absorb the vibration from the engine, preventing the vibration coming through to your exhaust system. So that's basically the product that they make. And they adopted Odin Checkpoint about 2 years ago. They basically were running their maintenance department essentially through these Excel sheets and paper-based task management solutions. And I like to call it word of shout as well, because that's how they kind of communicated, and a bunch of WhatsApp groups that they were using to communicate different issues and try to track different things and assign tasks and all that kind of stuff. So it's kind of typical. A lot of organizations are running on Excel, paper-based tasks, WhatsApp, and shouting across the factory floor to kind of get things done. And from a leadership perspective, they wanted to go paperless. They understood that it made sense. And so we basically deployed Checkpoint, where they started to digitize all of their tasks. We could assign responsibilities. We could check that tasks were done. And it was really a fantastic solution, and it made perfect sense. But interestingly, the adoption rate was really low at the beginning. And again, it came down to that middle management layer that was feeling vulnerable to adopting the technology, because leadership could now see every step that the technician did. And if the technician didn't do it, questions were asked to the management team, why did the technician not perform the maintenance task, as an example. And one of the key drivers to the success and the adoption from management was actually an interesting dashboard that we created for them, was this auditing dashboard. So this particular customer, SJM, gets audited on a monthly basis by their customers. So the likes of VW, etc., would come and do audits on their maintenance schedules and their PMs, etc., etc. And so we created this dashboard that showed all of the tasks that were done live. And so now that the auditor comes along and basically looks at this dashboard for 15 minutes, can click through some of the reports, and they basically have coffee for 2 hours and they kind of talk about the weather and sport, etc. And so this made a significant difference in the adoption rate from middle management, because it obviously solved a big problem for them. Their leadership was happy because the auditor from their customer was happy. But I just thought it was an interesting anecdotal experience that we had with a particular customer. When we created this one dashboard, it changed everything in that particular organization. And these are some of the stats that they've experienced. So a 30% reduction in downtime by just simply digitizing. And the reason for that a reduction in downtime was clear accountability as to who's supposed to do preventative maintenance. So it was John was assigned. Did John do it? Yes or no? And there was no admin to determine whether John did it or not. Some of the other significant benefits that they've had is this 14% boost in productivity, which means that I think they had like 24 technicians, which meant that as they were growing their organization, they didn't need to employ new technicians because they could do more with the technicians that they had. So that was a significant benefit that they had, as well as a couple of others that you can see over here. And the last case study I'll share with you is Copalcor. So these are the largest copper manufacturers in South Africa, and they adopted a Odin Raven, which is basically this vibration sensor that measures the asset utilization of a machine. So by using vibration, we have a machine learning model that runs on the sensor, and we can see when the machine is switching on and off, whether it's actually, if it's a milling machine, is it grinding or cutting and that kind of thing. And so we can get some insights out of the performance of that asset, not only health, but also performance of this particular asset. And the managing director of Copalcor really believed that they could get more out of their machine shop area. They were producing around 8,000 pieces per week, and he believed that they could get significantly more. And by adding these vibration sensors on I think there were 6 CNC machines, and measuring the utilization of those CNC machines and presenting the utilization data to the team, he believed that they could get and improve the output. And they actually did. So they went from 8,000 pieces a week to 11,000 pieces a week in only 3 weeks. And it was really significant and actually quite mind-blowing, even for us from a Jendamark perspective, to see this actually happen. And what they did was they simply created these 2 charts that showed the day shift. And wherever you see red, it means that the machine is not running. And wherever you see green, the machine is running. And night shift. And they put this on a TV in the machine shop area. And basically what they saw was 2 simple measures. The one was the time it took to move from a piece from one machine to the other was around 30 seconds to a minute on day shift, and on average on night shift was about 3 minutes. And then the time it took to start the shift and the length of the breaks, lunchtime, tea time on night shift, was significantly longer. And by simply measuring the vibration data, presenting this chart with no other intervention, they basically increased their production by 134, basically almost 40%. So that was, again, using data in the right way to change behavior on the shop floor. And the last slide I'll share with you is, this is, I think, a bit of a framework that we've kind of established with a lot of our customers, and we discuss this with them very early. So digitization is kind of 2 steps. The one is you digitize information, you organize it, and this is essentially eliminating the paperwork, creating visibility of that information. And then we start to automate a bunch of processes. So this is digitalization and streamlining a lot of the processes. And I think one important thing is to report by exception. The reason why this is important, you don't want to report and spam people with a bunch of information, because then nobody reads the messages and notifications become irrelevant. And that's a very important principle. But and then the last part, which is probably the most important, is actually to transform your business. And this is what we call intelligent enterprises, where they can use all of this information. And one of the important lessons that we've learned, and from a Jendamark perspective, from a technology vendor perspective, we can only deliver the first 4 steps. The last step is the customer's responsibility to actually transform, because we can't do the transformation in their organization. And one important message that we tell customers is that it's very important to start with a very simple digitization use case and see if the organization is mature enough to actually change. Because there's no point in spending millions and millions of dollars in step 1, 2, 3, 4 when you're not mature enough to actually change. And it's rather spend a little bit of money on a POC in a trial environment to figure out if you actually have the maturity to change, and then iterate and then grow the technology stack as you decide to change your organization. And I think this is where organizations like CCIG play a really critical role in this change management approach, because it's not easy. I actually think that the technology part is the easy part. The hard part, and it has always been the hard part, whether it be adopting lean, adopting digital, or whatever that might be, any change management in an organization is really difficult. And I think CCIG play a really critical role and can play a really critical role in this transformation of your business. What the change is really irrelevant, but it's how you change and how you go about changing. And I think that it's an important consideration before you start your digital journey. And then once you've been able to do a little small change, then you can change and create a lifestyle out of it and not a project. Yeah, so that's the last slide. I'll leave this up here. As Dino said, a selfish plug for my LinkedIn. Follow me on LinkedIn, and I kind of post at least twice a week on some interesting topic or at least an interesting topic I think might be beneficial to people. So yeah, that's it. Thank you, Dino and CCIG.
Thanks, Yanesh. Always great insights from your talks, very practical and very insightful, as I said. Maybe before we open up to other questions, there was just a comment type question from Ravesha saying I don't know if you can see it in the chat.
I'll stop sharing.
Okay, so it says for ISO compliance standards in the automotive industry, can the smart operator platform be incorporated to enhance compliance? And I guess from, we also deal with some other industries such as pharmaceutical, which is very, very compliance driven. And I guess these processes do make sense, but maybe you can comment on that as well.
Yeah, for sure. So I guess the one difference is that with ISO, it's a piece of paper to confirm compliance afterwards, whereas with digital, it's inbuilt compliance. So it doesn't go to the next step unless it's done correctly. So I think that's the advantage of digital, is that it's compliance inbuilt, whereas ISO is compliance and confirming afterwards. So for me, ISO's got its limitations, and compliance, paper-based compliance has its limitations.
Yes, it's built-in compliance. Like we have built-in quality, we have built-in compliance, which makes sense. Yeah. We do have Machuana, who's got a hand up. Have you got a question?
Good afternoon. I was actually trying to react to just clap, and then I raised my hand by mistake. Sorry.
Okay, no problem. Okay, there's also some good comments. Great presentation. So we're just opening up questions to the floor.
So just on the compliance thing again, I'll give you an example. Imagine you're driving on a freeway and your car is regulated automatically to the speed that it's supposed to be. So ISO is saying, give me a piece of paper to confirm that you were at the speed, whereas digital is making you drive at that speed. And that's, I guess, an analogy that just popped into my head.
Yeah, that makes a lot of sense. Thank you for that. Any other questions, guys? If there are no questions, we've made good time. So I'd like to, on behalf of CCIG, just thank you again, Yanesh, for your insightful presentation. And I'm sure we'll have you back again for another topic, maybe related or unrelated, but we certainly like having you here. So on behalf of all the delegates on the call and on CCIG, thanks again for your great presentation.
No problem. Pleasure, Dino. Thank you again for the opportunity.
Okay. And everyone have a great week. Thanks, Yanesh.